In other videos we've talked about different aspects of chemistry, but I thought it would be good in this video to tie some of these concepts together and talk about a particular chemical reaction, in this case the burning of magnesium. So here it is, here's the reaction. Magnesium reacts with oxygen in the air to form magnesium oxide. We've got one atom of magnesium on the left, oxygen goes round as two atoms bonded together, so we say it's diatomic, and on the right, our product, we have magnesium oxide. Now, this is not a balanced equation because we've got two oxygens on the left and one on the right. Now you might think, let's just get rid of this 2 and everything will be okay. Unfortunately, that's not allowed. You cannot mess with the little numbers. For the same reason here, you can't just stick a 2 in here. There is no such thing as MgO2, doesn't exist, can't exist. So that is not allowed. Don't mess with the little numbers. So we add another magnesium oxide molecule in here, and that solves the oxygen problem. But now we've got 2 magnesiums on the right and one on the left, so add another magnesium. And here it is, balanced symbol equation for the reaction we're looking at. Now, this reaction is exothermic, outside heat. It gives off heat, and this graph describes that kind of reaction. This shows that we have to put energy in to break the bonds. This is the activation energy barrier, and if you want this reaction to start, you have to put this much energy in. Now in this reaction we're going to do that with the Bunsen burner. We're going to add heat energy, and it takes energy to break those bonds up. Then once they're broken, you can get the rest of the energy out of the chemical reaction. Have a look here. We start off with this much energy in the reactants and we finish with this much energy in the products, and that extra energy is liberated as heat. Now, before we look at the experiment, I would like you to make a prediction, and this is it. If I weigh a piece of magnesium, I burn it and then weigh it again, is it going to be lighter, is it going to be the same, or is it going to be heavier? Okay, so take a piece of magnesium, weigh it, then burn it, then weigh it again. What do you think? Heavier, lighter, or the same? So you can see here we've got magnesium, and it's a shiny metal and you can bend it so it's malleable. Now let's measure the mass of the crucible with its lid and the unburnt magnesium, and we can see that it comes to 36.83 grams. Now to get this reaction started we need to break some of these bonds, and for this to happen we need to overcome that activation energy barrier we mentioned earlier, and this is achieved by using the heat of the Bunsen burner. Now occasionally I'm going to need to take the lid off of this crucible to let some oxygen in, and just to check the progress of the reaction, and at this stage it's just starting to react. At this point the reaction is progressing nicely, exothermic, lots of heat energy being given out, and now it's time for the moment of truth. So has it lost any mass, has it stayed the same, or has it gained any mass? And we can see here with a mass of 36.94 grams it's actually gained mass. It's gained 0.11 grams. It's gotten heavier. So here we have the final product, magnesium oxide, and you can see it's nothing like either of the reactants. It's white, it's brittle and crumbly, so nothing at all like magnesium or oxygen. So why did the mass increase? When we weighed the magnesium the first time round, we were weighing only magnesium atoms because the oxygen was floating around in the air. So look what happened to some of the oxygen atoms. They've broken free from their pair and they've bonded with the magnesium atoms. So we can now weigh the oxygen as well because it's become part of the solid. So oxygen does have a mass, and that's why it got heavier. Right, I will leave you with something to think about now. If I weigh a piece of bread, cook it, then weigh it again, will it get heavier, lighter, or the same? Well, I'll tell you, it gets lighter. When you cook bread, when you turn bread to toast, it gets lighter. But can you tell me why? Thanks for watching.